Hey everyone, welcome back to another video in the Golang series. In this video, we are going to talk about structs. This is something I discussed while we were making our first web server. So I made a struct saying it's a user, it has some ID, it has some name, and then we used this particular struct to to store the value that whatever we were getting from the request that the user was sending. But what exactly are structs? Struct is nothing more than a collection of data that we store. It's a user-defined data that can store a collection of things. For example, if I say I'm a user will have a lot of properties like a name, it has age. If I'm talking about my address, it will have city, it will have state, like country, and so on, right? So if I want to collect all these things, that is when I make a struct. So Golang by itself is not an object-oriented programming language. It has no concept of classes. But if we do talk about classes, this is somewhat what we used to do, right? If I were to make a class user, it will have certain properties like the name and age, which we would store, and then it would have certain methods. Now, there are certain similarities, but struct is not the same as class. It is just a way where we store our data. So, for example, if I want to make a user, I can just simply say user. It's of type user. It has name, which is going to be, let's say, Chirag, and it will have an age, which is, let's say, 22. And let's say I just log it as well for now. Log.info dot message user. Such if uh, user is percentage %b, let's say user. Okay, and if I print it, I get everything. Great. Uh, Now, there's also a possibility. Now, as I just mentioned, it's just a way of collecting data. So a struct can also have more structs within it. So let's say if I just say address and it is of type address. Great. So now if I were to make this, what I would have to do is address and what is it equal to? It's of type address where it will have, let's say, city is Bangalore, and what is state is just going to be Kar- Karnataka. Okay. Um, and what if I just print it now? Great. It's a struct within a struct or a JSON within a JSON, whatever you want to call it. Now, this is quite useful when you are interacting with, let's say, a user request. You want to store what the user is sending, or when you are interacting with your databases and you want to, store or update columns. When you just want to hold data in your app for some time and then you want to do some things, that is where you primarily will be using structs. And how do you access data? It's simple. You just say user dot and you get address age, address dot city, state. Great. So let me just write at uh, we need to log it. Log dot info dot message and it will have great. And there you go, Bangalore. And I think if I just write address dot city, no, it doesn't work that way. My bad. Okay. Now, one thing that we did in the last video was I added something like this: JSON ID, JSON name. Why? Now, this is part of the JSON validation which Jin provides. So, basically, what it is going to do is it will have certain rules behind this. So, what I'm basically trying to say here is that this user it will come in as JSON format, and the key that the user will send. So when you're trying to send a request, right, you send something like ID and let's say one. or uh, when this is 1. So basically, the ID that the user will send the request, which will have a small I, that is what I'm saying. It's an alias that I'm creating over here. So there are some things that you can do. For example, there's a great article that I found. I'll share this link. Um, let's see. So it's defined a body which has first name, last name, and if you see it has first name binding required, this basically means you cannot skip this field. If you skip it, it will throw an error. Then last name again required, again throw an error. For email, it says binding required and email, which basically means this particular field is of type email. And when you say of type email, it basically means something at something.com. So if it is not the format that is being followed, again throw an error. Then for phone numbers, again it's required and it follows EI64, which is some standard through which we measure phone numbers. Then there's country, which again says required, and then there's ISO 3166 Alpha 2, which is again standard that we follow for writing country codes. So I mean this is the expected response. So let's say over here instead of US, if I write A, now this country code violates the binding, so it will throw an error. And when you try and uh, extract the response over here, it will throw in an error. So this is basically what it means. So I'm not going too much into detail about the bindings. I'll share the link. You can read through it. We'll discuss a little more when we make our next web app. So I'm saving it for then. You can also define again your own formats that again they've added over here. You can go through this. All right. One important thing to remember, probably the most important. Uh, in Go again, there's no concept of public or private variables. I mean, not in the same sense as you do in an object-oriented programming language. You do not have uh, private or public keyword. So. Uh, cap you can see all these fields, they have this capital N, capital A, capital letters basically. They specify capital letters mean public, and if small letters mean private. Now they are private only to the packages where they might be exported to. So, for example, in this main package, if I am constructing user and if I say small n, it is still visible to this main package itself. But if I were to use it in some other package, then you won't be able to access it. So please remember this. It's the same rule for functions and any other field that you might define. So please remember this part. All right, so that is pretty much the gist of what structs are. Now, if you're coming from, if you have any knowledge about C, then you know C also does not have object-oriented programming, right? So basically, if you were to make something like a linked list or maybe a tree, again you would use structs. So let me try to make a quick linked list and show you how it works. Type node at its struct. It will have, let's say, a value which will be of type int, and it will have a next which will be a reference to the memory of some node. So let's comment it out, and let's say I define a head node which is going to be a node, and it will have, let's say, value of 1. All right, and let's say I make one curve which is gonna be of type head, and let's say I make nodes. I can probably write it in a better format, but that's fine for now, I guess. 2, 3, 4, and for I arrange nodes, What do you want to do while you iterating? You make a temp, which is node. It will have value, which will be what? Which will be I nodes I. That's it. And what's gonna happen? It's so basically cur dot next is gonna be the address of this uh, temp node. My bad. Address of the temp node, and we are gonna say cur is equal to cur dot next, and that's it. And to show you that I actually created the linked list, I'll just say cur equal head once more, and for cur not equal nil. All right, my bad. I had this. So basically, the cur should also be the reference for this head. My bad. Let's say we have log setup. Great. We have log dot info dot message. Let's say cur dot value. Now what? Switch f cur value is percentage v. All right, and we want to move cur dot next. Cool. Let's see if this works. Let's clear this first. There you go. Great. Um, so again, this is pretty much all we need to know about structs for now. Please remember this information and how to create a struct. That's very important right now. And a small homework assignment for you. Homework. Create a doubly linked list. All right, that's it for this video, and I'll see you guys later. Bye bye.